Hey seniors, welcome to another day working with equations. Today we're going to be focusing on number of solutions to equations. So we're still going to be working on solving equations and then figuring out how many solutions there are. So let's jump right in. On your notes page, go ahead and draw your line. On the left-hand side, go ahead and write number of solutions to equations. Don't worry about this yet, I'm going to tell you what to write. So when I'm solving equations, there were three different possibilities. An equation can have one solution, infinite solutions, or no solution. So let's go ahead and talk about each one of these individually. So when I'm given an equation and it has one solution, that means that x equals a number. So if I was given an equation and I came out with x equals 5, that equation only has one solution. And that means that I can only plug in 5 to that equation and have it equal on both sides. This will make more sense once we get into some examples. We're just taking notes for now. The second possibility is that an equation could have infinite solutions. I want you to write one solution, the definition, and then infinite solutions. If an equation has infinite solutions, infinite means countless, infinity. There are millions of solutions. And I know that an equation will have infinite solutions if the number equals itself. So if I come out with 5 equals 5, that number is equal on both sides, so that means that equation has infinite solutions. And then the last one, where an equation might have no solution. And you know that that will be the case when a number equals another number. And again, this will make more sense once we start doing some examples, but I just want to make sure that you have these three written down on your notes page. You're going to need them to refer back to when you start doing problems today during practice. So let's go ahead and do an example. So go ahead and write negative 3b minus 5 equals negative 2. Now, again, in order to figure out how many solutions this equation has, I need to solve for b. So let's go ahead and do that. I'm going to go ahead and write it here so it's a little bit bigger. So I have negative 3b minus 5 equals negative 2. And the name of the game is still the same. I want to get my variable to one side and my constants on the other side. So in order to get 3b by itself, I need to get rid of this negative 5. So the way I get rid of a negative 5 is to add 5 to both sides. Negative 3, I'm left with negative 3b, and then negative 5 plus 5 will just give me 0. So I'm left with 0, and then negative 2 plus 5 will give me a positive 3. Since negative 3b plus 0 is just negative 3b, that's all I'm left with, and then I'm left with 3 on the other side. I'm going to go ahead and solve for b by dividing by negative 3 on both sides. My negative 3's will cancel out. I'm left with b equals negative 1. Now, think back to our list that we just said. If my variable comes out to a number, if I have a variable equaling a number, that means that I have one solution. So this problem only has one solution. And the reason is because negative 1 is the only number I could plug back in here in order to make both sides equal. And let's go ahead and prove that. So again, if I want to check my work, I can just plug negative 1 back in. So I'm going to have negative 3 times negative 1 minus 5 equals negative 2. Negative 3 times negative 1 is a positive 3. Minus 5 equals negative 2. This is subtraction. I know I don't like that, so I'm going to keep, change. 3 plus negative 5 is going to give me negative 2. So again, this equation has one solution because negative 1 is the only number I could plug in for b to make that equation true. Let's do another one. Oops. Come on, pen. All right. Go ahead and write down 2x plus 10 equals 2 times x plus 5. All right, so in order to solve this, I see immediately that I'm going to have to distribute. In fact, I'm going to write this a little bit larger so we can see it a little bit easier. All right, so I have 2x plus 10. That's going to stay the same. If I distribute, 2 times x is going to give me 2x, and then 2 times 5 is going to give me 10. Now, I need to get my variable to one side. So I'm going to go ahead and subtract 2x from both sides. And this is where it is super important to see, because my 2x's are going to cancel out on both sides, because 2x minus 2x is going to leave me with 0 plus 10. And 2x minus 2x is going to leave me with 0 plus 10. And if we look back at our list, 0 plus 10 is 10, and 0 plus 10 is 10. And since a number equals itself, that means that this equation has infinite solutions. And what that means is that I could plug any number into this equation and make it true. So I'm going to go ahead and show you guys that. Let's say that we plug in 3. So again, I'm just plugging in 3 for x. So 2 times 3 is 6 plus 10. And then 3 plus 5 is 8. 6 plus 10 is 16. And 2 times 8 is 16. So again, I just picked a random number and I plugged it in. And that's going to be the same. This equation, I could plug in any number for x, and it's always going to be true. I'm going to get the same number on both sides. So that equation, again, has infinite solutions. It just means it has countless solutions. All right, let's do one more. All right, if I have 9x plus 2 equals 9 times x plus 3, again, I see immediately I'm going to have to distribute. Again, I'm trying to solve for my variable. 9 times x is 9x, and then 9 times 3 is 27. So again, I'm going to go ahead and subtract 9x from both sides. Again, I'm trying to get my variable on its own. But again, I see that 9x minus 9x is 0 plus 12 equals 9x minus 9x is going to be 0 plus 27. 0 plus 12 is 12, and 0 plus 27 is 27. There is no way to solve this problem. I don't have any variables left, and 12 definitely is not the same as 27. So that means that this equation has no solution. And that means that there is not any number I could plug in to this equation for x to make it true. So anytime you get these wonky numbers that don't equal each other, that always means no solution. Let's do one more really, really quickly. All right, if I have 7m plus 11 equals 2m plus 6, again, I'm trying to solve for my variable. And again, we're looking to see, does it have no solution, infinite solutions, or does it have one solution? So again, I want to get my variable on its own. I'm going to go ahead and subtract 2m from both sides. Again, it doesn't matter, but I'm going to choose to move that way. 7m minus 2m is going to be 5m plus 11. 2m minus 2m is going to give me 0 plus 6. And then, of course, I know that I'm left with 5m plus 11. 0 plus 6 is just 6. I want to get my variable on its own, so I'm going to subtract 11 from both sides. My 11s will cancel out. I'm left with 5m equals negative 5, because 6 minus 11 is negative 5. I'm going to solve for m by dividing by 5 on both sides. My 5s will cancel out. I'm left with m equals negative 1. So since m equals negative 1, that is my answer, but that also means that this problem only has one solution, which means there's only one number, which is negative 1, that I could plug in to this equation to make it true. All right, guys, that's it for me. Let's go ahead and practice.